Hello, Mark Palmquist again. Today I'm gonna show you how I make a mast. I'm gonna make a new mast. It's gonna be made out of poplar, and it's gonna be hollow. The reason I'm making a new mast is because I'm making a new sail for my Spark sailing canoe. It's gonna be 91 square feet, or I think it's 90. But my other mast was 9 foot 7 inches, and I need something that's basically 11 feet. And I have a method that's going to be easier than doing it the way other people suggest to do it. Okay, here's the layout of the boat. There's 11 foot or 3.3 meters. This is one way to do it, where you basically mill a bunch of basically boards that are 1/2 inch thick, and you glue them together like this. The problem is boards don't come in 1/2 inch; they come in 1 inch. So I got 4/4 poplar, and I'm going to plane it down to 24 millimeters, which is about 15/16, and then I'm just going to glue these little pieces in here. I'm actually making it go quicker using the dado blade on the table saw. Otherwise, I'd be planing this for like a half hour to get it from 1 inch thick to a 1/2 inch thick. Okay, there's the results. The bottom of the mast. What I did was I just plunged the blade. So this part is going to be solid. This is the bottom of the mast. So, excuse me. The maximum stress on any mast is always the middle. So there's stress on the bottom and then the deck. So the deck is around 14 inches. And this right here is maximum stress. So you want to go above, you want to go beyond the point of maximum stress, which is the deck, another 6 inches or so. Okay, and there is the cross section of the new mast. The walls are slightly over 1/2 inch, which means I can plane it a little bit on all 4 sides and make it exactly a 1/2 inch. And I'll get a perfect square as well. It's important to note that see how the two pieces are bowing inward? They have to bow in the same direction, and you have to have a nice flat work surface that so my work surface has a little dip in the middle, and that's why I put this piece of masonite in there, which I actually planed with my planer. So now this whole table is nice and flat, and when I do the glue up, it'll make the mast nice and flat as well. So this is the bottom of the mast. It will still have a slight hollow section, but it will be about half as deep. Okay, there it is, glued up. I rotated the clamps so that it would remain nice and straight. Here's the bottom. It has a hole, but I can plug that. Okay, here's the mast, the rough blank. Now I'm going to run it through the planer and clean it up, straighten it out a little bit, and then radius the corners. Okay, there it is, planed down. It's nice and square. It's 60 by 60 millimeters square. There's the old mast that I had that was made out of ash, slightly shorter and less diameter. Now I just gotta plug this and plug the other side and radius the edges. Okay, let's see how much these weigh. I'm just interested to see how this compares to the All right, that's 9 pounds, 3 ounces. That's ash, and it's 1.5 feet shorter. Ooh, this feels heavier. Okay, it's over 10 pounds, which means it's beyond the capabilities of this scale. Okay, so it's 10.5 pounds. Okay, I ran each side through the planer twice, and then I rerouted the corners. Ooh, 10 pounds, 15 ounces, which means 11 pounds basically. Okay, looky. It fits in the canoe. I think this is a requirement that the sail rig fits inside the canoe. If you want to participate in, I think it's, I forgot what group number. It's Everglades Challenge Water Tribe. Basically sailing canoe with an outrigger or two. So the key is you have to have a lee board to qualify. Otherwise it's just a trimaran. So okay, here's the plug that I made for the top of the mast. It has to go in far enough so that I can drill a hole right here and it'd still be waterproof so that water doesn't go flood the inside of the mast. I'm almost there. It just needs a little bit more tapering. Okay, that's good. That's how deep it goes in now. So go ahead and glue this in. Using Type Bond 3, and I'll probably add some sawdust in there to thicken it a little bit. Okay, there's the thickened Type Bond 3. All right, there's the plug. Okay, here's the plug for the other side. This is the bottom of the mast. This one's not as critical. There's no holes being drilled or anything, so it just has to be tight. Actually, I don't think I need to thicken it here. All right, you don't want to pound it too hard or else it'll split. Okay, it turns out that the diameter or the width and the cross section of this is too big to fit in the hole at the bottom of the boat. So I have to create a shoulder and shrink it a little bit right here. So first I took this, set it at 3/4, which is the thickness of the bottom, and just scratched a line like this all the way around. Now you just basically take a sharp chisel and stick it in there. I need a wooden mallet for this. All right, now I'm going to use a router plane. It's basically a plate. It's got a cutting bit. Let's see if it fits. So because this mast is so big, it has to go in the front hull because the sail is bigger, the boom is bigger, so the center of the sail is further back. That's why I always make at least 2 holes on my boats, sometimes 3. It's a whole lot easier to move the mast than it is to move the dagger board or the center board or the lee board. Alright, so that fits. That's good. Alright, so what I'll have to do is I'm going to leave this ring here, but I'm going to make another, I think it's called I forgot what it's called, a dog or something. It's got to go right here, right below the boom, so that the downhaul, the thing that pulls down the boom has to be directly above it. Otherwise, when the boom, when you're going downwind and the boom goes around this way, it'll tighten the sail. So it has to be directly here. So I'll just make another one of these right here. The last step is to drill the hole for the halyard. Using 8mm, which is 5/16, using this to keep it nice and straight. Now I'm just going to countersink the holes. Okay, so I just bought a new can of shellac. I just stirred it up. It's very important that you stir it. So this is going to be sitting at the bottom of the boat. It might be wet down there. All this end grain has to be sealed really well. Ooh, let's see. Wow, really. All right, so this is called a French dip. Or at least that's what somebody called it once. They do this for gun handles, the wooden handles on guns. They dip it like, I don't know, like 3 or 4 times in shellac. Okay, so one comment I want to make. So I started out with 1-inch thick poplar. And if you buy poplar at a lumber yard, you can get it that thick. If you buy poplar at Home Depot, which I do not recommend, you're going to be paying a whole lot more, and it's already going to be planed to 3/4 of an inch. It's almost like you're paying an extra 25%. So I'm a woodworker. I do not buy wood at Home Depot. It's good for you can get plywood there, you can get 2x4s there, but do not get hardwood. Go to a lumber yard and buy it there, or a hardwood supplier. All right, here's the top of the mast. I rounded the top. It's got the hole in there. Okay, let's not hit the ceiling. Wow, look at that. Okay, I'm trying not to make it overflow because I don't want it to overflow. Okay. So I've never bought a piece of poplar at Home Depot or Lowe's or whatever. Okay, so when you do this, a French dip on the ends wherever there's a hole, the point of this is so that when you run your halyard through that hole, the halyard is going to basically smooth the surface. So one thing that shellac is used for is a sanding sealer. So what that means is you can sand the shellac once it dries, and because I can't really get in there and sand it, the halyard is going to sand it, and when you sand shellac, it becomes really slick and slippery. If I had just dipped this in a can of oil, it would not have the same effect. So I am putting oil on top, marine varnish on top of this, but I'm going to wait till the shellac dries. So Okay, one more thing that I did, my tiller was too short last time I went sailing on the Spark sailing canoe, so I made a longer tiller. You can see here, this is where the shellac is, and then I used marine varnish. Actually, I shellacked the whole thing, and then I just finished it off with some of this Osmo UV protection oil. Okay, there's one more very interesting thing that I'm doing that's different. This is my new yard. This is for the top of my sail. If you look at it, it's a D-shaped cross section, and then it has this this 1/4-inch plywood flange, basically. And the reason I did it this way is I want to try moving away from the luff pocket and attaching the sail. I'm going to drill a hole here and attach the sail here and at the other end. And in fact, I'll probably drill a hole periodically like this. And the other thing that I'd like to do is, so with the top battent, the battent that goes at the peak of the sail, it's gonna loop through one of these holes and then go this way to the top of the sail, top rear corner. And in this case, I could even use 2 thin battens, one on each side of the sail, and they would be connected here. It would be a very rigid connection. So the battens that I used for my other version of the sail, they were too stiff, and they didn't bend. But if I use 2 thin ones and I put it on either side, it cuts down on the wind resistance. So this D-shaped yard is like, it kind of creates, it deflects the air, and then this little pocket in here it will create a little bit of a vortex in here, but it will help with attachment. So the flow, the idea is to keep the flow attached on the back side of the sail. Actually on both, but mostly on the back side, because that's where it usually becomes detached. And we'll see how this works. It's kind of like a D-shaped, mast, but it's for the yard instead of the mast.